beautiful South Studios of Way Happy. This is Mr. Meyer, and we are talking 1.5 parametric equations and apparently inverses too. And I didn't know. I did that a little early. So hopefully we can get through this video pretty darn quick because you're ahead of the game. So inverses, remember, switch x and y, solve for y, and that's an inverse. Now, parametric equation is an equation that adds something new. It adds another variable, and that variable is called a parameter. And specifically, that parameter is time. Time is what is introduced in parametric equations. It's kind of fun to do with projectiles, something flying across the room or anything that does have motion, and wanting to know where it is at a certain time is super helpful. So the way it works is we make parametric equations that look like this, right? They have an x and a y value, but notice they're in terms of t. Isn't that weird? They're in terms of time. So the way you would actually calculate where something is you would make a table of values and figure out the x and y values. And that's what this is. This says find the points that are determined by these times. So when time is -3, then what's the x value? Well, the x value is -3 minus 1, so it's -4. And the y value is going to be t squared, which is 9, plus 2 is 11. So it was at the location -4, 11. So if you wanted, you would go -4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a rude, crude graph, but there it is, right? That's when t is 1. And then t is 2. Then I'm going to plug in a -2, and I'm going to get -2 minus 1 is -3. And I'm going to get 4 plus 2 is 6. And then it's at -3, 6. So -3, 1, 2, 3, 4, 5, 6. There it is right there. I should probably use graph paper. And then I'd be at -2, 3. So -2, 1, 2, 3. And then I would be at 0, which would be -1. And if I plug in 0, I get 2. So -1, 2. And then if I plug in 1, I would get 0, comma, what is that? If I plug in 1, I get 3 again. So 0, 3 is right there. And then if I plug in 1, or in this case, my time is 2. The point I'll be getting is 1. I got a little ahead of myself there. Time is 2. I would get the point 1, comma. If I'm plugging in a 2, I get 6. 1, comma 6. 1, 2, 3, 4, 5, 6. And you can see this object is moving back up. And then as I plug in time is 3, I get 2, comma 11. And 2, comma 11 is back up here. And we might notice that shape. That shape was the same on the left side as it was on the right side. And so it went like this, right? It went whoop, came down, and then it went back up, traveling in a parabola. So that is what this was during that time. So it started at t is -3, and it started at the point -4, 11 again. Now there's your graph, right? Notice no arrowheads because it stopped. I only did time from -3 to 3. Now, if you wanted to, you could assume that the time went on and it continued down its usual path. That's a parametric equation. You use time to find out where something is. So t0 is usually like the initial time, and then it's like 1 second later, 2 seconds later, 3 seconds later. Or if I go in the negative direction, maybe it still was on that same path, and you could still use the equations to see where it was 3 seconds ago from now. Maybe t0 is now, and where was it 3 seconds before now? And so you could then try to explain where it was. Back to that whole modeling thing, right? Now, sometimes people don't like to do that. They don't like to do all that work, or maybe you're just curious, like, could I have been able to tell that it was a parabola before? And the answer to that is also yes. All you have to do is get rid of the parameter. So you could use substitution, you could use elimination, you can pick. And probably the easiest one for this would be to pick substitution, right? And what I mean by that is I'll make one of the equations say t equals. So I'll rewrite this one to say t equals x plus 1 by just moving the 1 over to the other side. And then I can substitute all of this in for t. So this equation becomes y equals x plus 1 is all there squared plus 2. Hey, that composition of function thing. And there it is. There's a parabola. And if you remember your parabolas, you want to practice, that was left 1, up 2, and that's kind of what my drawing looks like, a parabola left 1, up 2. Now notice time isn't here. This is a parabola that goes on forever. The end behavior, this is going to be infinity on both sides, not the one up above where the time stopped from -3 to 3. So that's a little bit different, but you can see what the graph should look like, and sometimes that is helpful. That's it. Stay happy, and I'll see you next time.